a plane designed to fly faster and higher than any of its rivals. The Boeing 2707. This is the story of Kennedy's dream, an aircraft at the cutting edge of technology. In the summer of 1963, President John F. Kennedy announces a major new aerospace program.
I'm announcing today that the United States will commit itself to an important new program in civilian aviation.
He calls for America to build and fly a supersonic airline that will cruise at over 3,000 kilometers per hour. One of John Kennedy's heroes was John Glenn, but Glenn was also the first man to fly America coast to coast at supersonic speed in the year 1957. Ever since that flight, Kennedy had dreamed of building an American supersonic transport. Others had that same dream.
The British began their supersonic aircraft program in 1943, midway through the war. It was a design, obviously, at that stage, which called for an aircraft to be capable of Mach 1.5. That's 1.5 times the speed of sound, or about 1,000 miles an hour.
The British had several projects. Among these were the Miles M52 and the de Havilland DH-108 Smaller. But Britain was beaten to the prize by Chuck Yeager, flying the American Bell X-1.
To tell you the truth, I was hopping mad, because I realized we could have done it and we'd missed the boat by cancellation. Not with the DH-108, but with the Miles M52. I was to be the pilot of the Miles M52, so I'd followed this carefully, and we were 80% ready for the first flight, when, without any warning, without any consultation, the aircraft was cancelled.
On October the 14th, 1947, the rocket-powered Bell X-1 became the first aircraft to fly faster than sound.
The British were really upset that the Americans had been first through the sound barrier, because British technology was ahead of the Americans. The British just fluffed it, lacked the guts to do it.
The reason the British gave for cancelling the Miles 52 was lack of knowledge surrounding what happens to an aircraft as it approaches the sound barrier.
When an aircraft approaches the speed of sound, several things happen. The most disturbing of which for the occupants of the aircraft is the aircraft begins to shake and rumble, depending on how rapidly or how slowly you approach the speed of sound. But in aerodynamic terms, a wave builds up, an area of compressibility builds up, a shock wave. And what that does is that causes increased drag and increased heating on the aircraft, such that as you approach the speed of sound, as the shock wave passes over the flying surfaces, what that does, it causes the wings to lose lift both above and below the wing. And that has a downward effect on the aircraft. So the aircraft will start to dive if you don't do anything else about it. You'll first start to notice the problem of approaching the transonic area, approaching the speed of sound from about 0.9, so 9/10 of the speed of sound at sea level. And there you'll begin to experience a buffet as the shock wave begins to build up. And as you approach the speed of sound, the closer you get to the speed of sound, the greater that buffet will be, until that moment when you pop through the other side and that shock wave is then traveling behind the aircraft. You then punch through into an area of far more stable air, an area of almost quietness, if you like.
By the mid-1950s, military aircraft were routinely flying beyond the sound barrier, but they did so only for short periods. Sustained supersonic flight was a much bigger problem than just punching a hole in the sound barrier.
Supersonic flight for passengers is actually very different from supersonic flight in the military context. If you're going to fly passengers at supersonic speed, you have to fly them for a long, long time at high speed, whereas military operations tend to be a quick dash.
Only one country decided to tackle the challenge. Defeated in the race through the sound barrier, the British now embarked on the design and development of a supersonic airliner. It was to signal the start of a race that would transform the world of aviation. On March the 10th, 1956, the British re-entered the supersonic stakes with a vengeance when the experimental Fairy Delta II captured the world absolute speed record at 1,820 kilometers per hour. The Fairy Delta II introduced a series of revolutionary features. A long, narrow delta, perfect for cruising beyond the sound barrier, and a drooping nose to allow the pilot a better view on takeoff and landing. Inspired by the success of the Fairy Delta, the British established a committee to coordinate the development of a supersonic airliner.
The most interesting aspect of the Fairy Delta II that we see on today's Concorde was the drooping nose. Now what that is it's simply, as you see on Concorde, a nose that kinks. One of the problems with the Delta winged aircraft, and an aircraft that is designed for going supersonic speeds, is that in order to fly very fast, obviously you need something that is as aerodynamic as possible. The problem is they are very, very difficult to fly at low speeds. So when they come into land, they have a very high angle of attack, and very, very difficult then for the pilots to see what they're doing. So they then put this kink in the nose, if you like, to have this cantilevered nose, such that in takeoff and landing, to give the pilots better visibility, they put this design feature in, which we see today.
In March 1959, the preliminary design work had progressed to a point where the Supersonic Transport Committee was able to report its broad recommendations.
There were two main recommendations. The first was for a small, fairly simple aircraft to carry around 100 passengers and do about Mach 1.2. The second design was for a 150-seater that should have been capable of Mach 1.8, which was considerably bigger and considerably faster.
By 1959, the British thinking had crystallized into two projects. A medium-range supersonic airliner, which had a rather crazy M-shaped wing, very difficult to build. And the other project was the classic, what's now the classic long, thin delta for a supersonic airliner that could fly across the Atlantic.
Now would emerge a decision that would shape the whole future of the race to build a supersonic airliner.
The design study contract in 1960, the British made it a condition to BAC, who got the contract, that they should seek international collaboration for the building of the supersonic transporter.
The first country BAC approached was the United States, but in 1960 there was little interest shown in the USA for collaboration. So the British turned to France as a potential ally.
Eventually decided to cooperate because the supersonic airliner project was just too big for either of them to do on their own. It was helped by the fact that the two different design teams in France and in England had more or less come to the same conclusion about what the aircraft should look like.
The aircraft was to be a delta-winged design. It was to be called Concorde, a word common to both languages, which means agreement or harmony. But to become credible, Concorde needed customers in the airlines. In June 1963, Concorde received the major airline order that meant it would fly. And the order came not from Europe, but from America's own leading airline, Pan Am.
Such a good customer that they could go in and play one aircraft factory leader against another. And Chip didn't mind going in threatening and saying, look, if you don't do this, I'm going to get somebody else to do it. And if I have to go to Europe, I'm going to Europe. Tripp was an overpowering figure in the industry at that time.
Pan American Airways began operations on October the 28th, 1927, with the first scheduled international flight by a United States airline. A Fokker tri-motor airplane loaded with mail flew from Key West, Florida, and landed 1 hour and 10 minutes later in Havana, Cuba, a distance of 135 kilometers. Pan Am's 28-year-old founder was the legendary Wham Terry Tripp. It was Tripp's original bright idea that planes carrying mail can just as easily transport people. Putting seats in the back of each plane, he charged $100 to fly to Havana. Tripp was determined that Pan Am would always be the #1 U.S. airline.
In the post-war world, in the 1960s, Pan American Airlines was one of the big names. Most American airlines tended to fly inside America, but Pan Am had built his reputation on flying all around the world. And they did that by always buying the latest and best aircraft.
On October the 26th, 1958, Pan Am became the first U.S. airline to operate a jet passenger plane, a Boeing 707 christened Clipper America. It flew from New York to Paris, halving the normal flight time. Juan Tripp was also determined Pan Am would be the first airline to go supersonic.
If you joined Pan Am as a pilot in the late 1950s or 1960s, the first thing they told you was, you hang in there, guys, because you are going to fly supersonic. Pan Am saw that being the first to be with the supersonic airliner as you know, the thing that would brand the company as the place to go.
But the Pan Am decision was to trigger an American response. Within days of the announcement, on June the 5th, 1963, President John F. Kennedy proclaimed his government's intention to support the American aircraft industry in developing and building a supersonic transport that American airlines like Pan Am could fly.
When Kennedy heard that Pan American were going to buy the European Concorde, he was apoplectic. He was furious. And he phones up head of Pan Am, Juan Tripp, and just gives him a bawling out. And Tripp says, well, you know, the alternative is you give me an American supersonic airliner. So from that moment on, Kennedy decides he is going to get a hold of the American aircraft companies and he's going to make them build a supersonic airliner faster and higher in performance than the European rival.
And so the race began.
The immediate result of Kennedy's intervention in the race to build a supersonic transporter was the appropriation of $100 million worth of funding from Congress, which in 1963 was a serious amount of money.
Concorde now had an American rival. The question then became, who was going to build it? One obvious candidate was Douglas, the major builder of civil airliners, from the fabled DC-3 to the jet DC-8. But Douglas was too strapped for cash to compete. Other candidates were North American, who were already working on a big supersonic bomber, the B-70 Valkyrie, and Lockheed, which had major experience of supersonic craft, such as the secret SR-71 Blackbird. There was also Boeing, the manufacturer of the mighty B-52 bomber, and the well-established 707 airliner series.
Of all the American aircraft companies, paradoxically, Boeing was the one that had the most trouble in getting into the supersonic airline business. Boeing hadn't actually delivered a supersonic aircraft to anybody.
Its founder was William Boeing, the son of a wealthy lumberman. In 1903, Boeing dropped out of Yale University and headed for Washington State to make his fortune in the timber industry. In 1910, William Boeing went to Los Angeles for the first American Air Meet. He tried to get a ride in one of the airplanes, but not one of the dozen pilots participating in the event would oblige. Boeing came back to Seattle, determined to build and fly his own planes.
Bill Boeing was, some people think he was an inventor, but Bill Boeing was an innovator of the highest order. I think he has very few patents, perhaps if any, but he would look at a product and he could see where he could make it better.
On July the 15th, 1916, Boeing incorporated his airplane manufacturing business in Seattle, in an old boatyard. He hired boat builders whose skills in carpentry were ideal for the new aviation industry. The early Boeing company prospered, building seaplanes for the US Navy, then pursuit planes for the Army. But it was World War II that brought Boeing to the peak of success.
The war was starting in Europe, and Wright Field put out an order for bids at this time, most of the airplanes were two-engine. We were still two-engine. Douglas was doing a two-engine bomber, and another company was doing a two-engine bomber. And Boeing went in to Wright Field and said, would this procurement cover a four-engine bomber? And everybody just went berserk because nobody ever conceived of a four-engine bomber.
This was the XB-15, a four-engine aircraft with a wingspan of 45 meters.
It was so big, you could tunnel out through the wing, and you could come into the nacelle, and you could make repairs in flight.
A smaller version of this giant would become famous, the B-17 Flying Fortress, that would fill the skies during World War II.
I think they ordered 13 or 14 what they call test airplanes, and that led to the Flying Fortress. I don't remember exactly how many were built, but it was around 13,000. And that airplane then went through the A series, B series, C series, all the way to H, as I recall. I'd say the story of the B-17 was it was such a versatile airplane, was able to keep carrying more bombs, more turrets.
As American men went to war, women built airplanes. Thousands of women took up the slack in the workforce and helped boost production at Boeing from 60 planes per month in 1942 to an astounding 362 planes per month by March 1944. The B-17 was followed in 1942 by the B-29 Super Fortress. In Wichita, farm hands, housewives, and shopkeepers built B-29s on 10-hour shifts, day and night, during what later became known as the Battle of Kansas.
World War II transformed the fortunes of the Boeing company. Before that, it was a serious manufacturer, but planes were built in small numbers. World War II meant Boeing was producing vast numbers of giant bombers on huge assembly lines.
After World War II came the B-47, America's first jet bomber. And on April 15, 1952, Boeing test pilot Tex Johnston made the first flight with the B-52, which was to dominate the skies for the next 50 years. Then, Boeing took a gamble.
In the 1950s, Boeing was doing quite well in military contracts for the B-47 and the B-52 bombers. But no aircraft company, can afford not to look ahead because it takes a long while to develop aircraft. And so they took a bold decision. They decided, well, let's take some of the profits from the bombers, some of that technology, and see if we could mix that into an aircraft that passengers would want to use, that the airlines would want to buy.
We had all the knowledge of the B-47 and the B-52, so it wasn't too big a job in the wind tunnel to develop a low-wing airplane that could be used as a tanker. And we knew they needed a tanker, so there had to be a tanker. And we hoped it could be a passenger airplane, although we weren't really sure that that was the case. So that's why the Dash 80 was born.
The Dash 80 took to the air under the control of Tex Johnston, who had flown the B-52. Johnston was determined to show Boeing had built a great plane. So he barrel-rolled the Dash 80 over the Seafair hydroplane course on Lake Washington on August 2, 1955, a maneuver that only nimble fighter aircraft usually do. Boeing's president, William Allen, was there to witness it.
And Allen turned completely white, looked over at his technical advisor, Wellwood Beale, and he said, "Did we authorize that?" And then just before he could turn around, here he came back again and did it once more.
Boeing's gamble paid off. The Dash 80 became the prototype for the KC-135, the first jet aerial tanker. And that turned into the Model 707, the first in a long line of Boeing commercial jet airliner. Boeing had done something clever with the 707. Using about 1/10 of the fuel, could carry as many transatlantic passengers a year as the $30 million Queen Mary ocean liner. Boeing had created a market and killed the passenger liner. In 1958, with the 707 entering service with Pan Am, Boeing set up a small group to concentrate on developing a supersonic passenger aircraft. By 1960, the company was spending over $1 million annually on the project. The design was designated the Boeing Model 733.
Boeing actually started work on supersonic passenger airliners very early on, right at the beginning of the 1950s. But in a kind of research way, is this possible? Where are the engines going? Where is the metallurgy going? But what you begin to see is by the end of the 1950s, they're starting to get quite serious about it. They're beginning to think this can be done.
With Kennedy's call for America to actually build the SST, the Model 733 could become reality at last. Throughout late 1963, the three contenders for the prize of building the American SST, Boeing, Lockheed, and North American, worked in secret on their designs. Could the late American competitor still capture the market? In late 1963, metal for the first Concorde was already being cut. Would America catch up? There was a recent precedent. The British Comet had been the first jet airliner in service in the 1950s. But a series of fatal crashes revealed serious design flaws that had resulted from the Comet being rushed into airline operation to beat the Americans. As a result, the Boeing 707 came from nowhere to dominate the skies of the 1950s and 1960s.
The Americans came late to the supersonic race. They wanted to leapfrog the Europeans, and so they decided to go faster. The Europeans were going for Mach 2.2, which meant they could build Concorde out of existing materials using existing technology. The Americans decided to go way up to Mach 3 through the so-called heat barrier, which meant that because of the stresses on the plane at those speeds and the heat that would build up on the fuselage, they had to use new materials. So the Americans were going for a technological breakthrough to try and get ahead of the Europeans and bury the competition.
To beat the competition, both at home and in Europe, Boeing proposed a plane that was far bigger than Concorde. It was designated the 2707.
Boeing realised that if they were going to beat the Anglo-French Concorde, they would have to be bigger, better and faster. So their design was for a faster aircraft and for one that would carry 2.5 times the number of passengers as Concorde. So instead of 120, we're looking at 277 passengers on board.
To help design its new 2707, Boeing built an amazing life-size mock-up. The aircraft was 93 meters long, a third bigger than Concorde. There were 277 seats, 30 first class and 247 tourist. 2.5 times the number of passengers the small Concorde was designed to carry. The seating layout in the 2707 was revolutionary. Till then, seating in planes was 2 cramped seats on either side of a single aisle, which made planes seem very claustrophobic.
Boeing decided that in order to entice people into this new aircraft with these fancy speeds, they'd have to offer a bit of something else. And so they made the fuselage bigger so they could get more seating in. Today we are very used to three sets of seats, 2 aisles. But this was the first time when Boeing was developing the supersonic airliner that they decided to introduce that into an aircraft.
By comparison, the Concorde has a very narrow fuselage and the old-fashioned till-abreast single-aisle layout. The 2707 would be powered by 4 massive turbojets, each capable of generating nearly 3 tons of thrust. At takeoff, the 2707 would weigh over 300 tons.
Boeing 2707 had two other very interesting features. The first was a drooping nose, not unlike we see on Concorde today, to allow the pilots much better visibility in takeoff and landing, and then to be flicked up for that needle-like high-speed flight. The second design feature was also to do with the differences between low speeds for approach and landing and high speeds in supersonic, and that was the swing wing. The wing was able to pivot for those slow speed areas, making it easier and safer to fly when taking off and landing. But then when it was up above the Atlantic or Pacific or wherever it was going to go and approaching its speeds of Mach 2, you could sweep the wings back and get a very similar effect to the Delta.
The wings on the mock-up of the Boeing 2707 could be moved manually from fully aft with a 72-degree sweep to fully extended with a 30-degree sweep.
The Boeing Supersonic airliner was really pushing the boundaries of aviation technology. They were going to go faster, they were going to go faster for longer, which meant new materials, new kinds of engines, new kinds of avionics. It was a risk.
One group who thought that were the Lockheed Company, who were busy with their rival SST, the Lockheed L2000.
The Lockheed design for a supersonic airliner was simple, elegant, beautiful. No complex moving parts like a swing wing. They'd adopted the narrow delta that everyone knew was going to work. It was within the boundaries of what was possible. They were minimizing the risks, and that's why it was a serious competitor.
As the time for submitting final design entries drew closer, Boeing was still plotting to outdo the competition.
As the design process went on, it became obvious that the Boeing entry was going to be terribly complex, terribly expensive. That made the airlines who were going to have to buy and use the thing frightened. So Boeing started adding on more and more passengers in the hope that it could make a profit that would make up for the escalating costs of the aircraft in the first place.
Size does help you a little bit on efficiency, at least it has on the other airplanes, and so obviously you can go overboard and be too fast, but too big. But I think that we felt the Concorde was too small to be a successful system.
It was the last day of 1966 when the final design winner was announced. It was the revolutionary Boeing design.
I think it was a very tough competition. The reason we won the configuration was not necessarily that the airlines liked our configuration any better. My personal opinion is that I think that they felt that they would rather have Boeing build their commercial airplane than the other two manufacturers, because we were in the process of building commercial airplanes at that time and been working with the airlines, and my personal opinion is that we were picked as a company, not as a design.
It was a surprise that Boeing won because they had so little experience in building working supersonic aircraft. I mean, they were famous for the B-52 bomber, which is subsonic. Everyone else, I mean, Convair, Lockheed had built large and fairly successful supersonic aircraft. So this was the new guy on the block suddenly being given the job, and everyone thought, can they do it?
Boeing predicted that if design and construction of prototypes began early in 1967, the first flight could be made in early 1970. The first aircraft could then be ready for airline service in mid-1974. They were talking nonsense. They had no idea of the problems they were about to face.
The main problem in designing the Boeing supersonic airliner can be summed up in one word: the weight. This thing just got fat. It got heavier and heavier. It wasn't going to make money. They had to then strip out weight, and in the end, the biggest weight penalty was going to be the mechanism to make the wings swing.
As we got beyond the preliminary design stage to build it, the weight got too heavy. The empty weight got too heavy. That was the main problem. The weight just got out of hand, and we couldn't meet the weight statement that we'd estimated for the configuration at the start.
The project slammed to a halt for a year as Boeing considered alternatives. In October 1968, Boeing emerged with what was virtually a complete redesign.
There was only one way to solve the weight penalty problem. That was to take the swing wing out.
Boeing's swing wing disappeared mostly because of the extra weight. That huge hinge in there was very, very heavy.
The 2707 was also reduced in size. Seating was reduced to 234 passengers, though that was still bigger than Concorde. And now, a new problem appeared to haunt the project and eventually kill it: the sonic boom.
We knew it existed, but frankly, I didn't think it was that bad. The sonic boom that the airplanes we were talking about was like thunder and lightning, where the thunder hits about 2 miles away. And I guess I just didn't figure it was that bad.
In order to explore the effects of the sonic boom on, for example, urban areas, the American Air Force conducted an experiment in 1964, which is something I don't think we would ever contemplate doing today. And what they wanted to do was see what effect it had on an urban area. So they flew supersonic bombers over Oklahoma City with sonic booms or waves of shocked air passing all the time. The result was that in a very short period of time, they had around 8,000 very vocal complaints and around 5,000 complaints for claims for damages.
In 1967, immediately after Boeing had been selected to build the 2707, Dr. William Shurtleff, a scientist at Harvard University, organized the Citizens League against the sonic boom.
Well, actually, there were so many technical and economic hurdles that had to be addressed for an airplane like this, not the least of which was the sound. Reaching the sound barrier always created a shock wave over populated areas.
Well, that era was a miserable era for me, because here I was, an engineer trying to do things, and you had these idiots back there making it was a political situation, and he just dumped on it. This guy Shurtleff, I never met him. I don't know what his problem was. I know the British were taken by surprise on it. They were completely amazed at the problems we were getting.
Other scientists hypothesized that the exhaust from SSTs, expelled into the atmosphere at high altitude, would start a self-perpetuating chemical reaction that would ultimately deplete a radiation-absorbing layer of ozone in the stratosphere and bring on an increase in skin cancer.
I think there were other environmental concerns, perhaps not substantiated technically, about the ozone layer, about contamination of the upper atmosphere. There were all sorts of boogeymen shoved into the front of the table having to do with so-called environmental problems.
But public opinion was turning against the SST. And as resistance grew, Congress itself began to express doubts about the plane. In response, President Richard Nixon, shortly after he was elected in 1968, appointed a 12-member committee to report on the project.
Nixon was a firm believer in the SST when he came to power, like Presidents Johnson and Kennedy before him, and he felt that the SST was essential to American prestige. And in order to underline the case for the SST, he appointed a committee. To his great surprise, I think, and consternation, the committee came out against the SST and decided it was completely unviable.
Apart from the sonic boom, the Boeing SST was encountering other problems. When he set the goal for the American SST, President Kennedy had decreed that it would fly faster than its European rival at Mach 3. But at that speed, an aircraft's skin becomes red hot. You have to make it of expensive materials that will not melt or crack at those temperatures.
To reach the speed that the 2707 was going to go at, you had to find new materials to deal with the buildup of heat. The most effective material would be titanium. And at that time, titanium was really, really complex to machine, very expensive to get a hold of. it was going to make the whole project uncommercial.
It's tough environment, and temperatures in Maine is a real big problem. Whether you can ever design a structure to meet all this and still have enough left over to make any money with is not too clear at this point.
The British had long since decided that these problems were too difficult and expensive to bother solving. Concorde would fly at less than 2,000 kilometers per hour, where the heating problems were much reduced. Concorde could therefore be built out of standard metal alloys to keep the manufacturing costs down.
You went much faster than Mach 2. We got too hot for aluminum. I don't know. Aluminum, I can't tell you exactly, but you wouldn't want to go too much beyond 2 to get to with aluminum, so you needed a better material. And titanium was quite capable. It was a good material, and we felt that it would be. So part of the program was learning how to manufacture.
As Boeing's engineers grappled with the problems, the 2707 program suffered delay after delay, while costs skyrocketed.
We spent several $1 million of our own company money in working titanium on the side of the outside of the contract on the SST, but maybe we were too ambitious. It might have worked at 2.5 Mach number, but I think that you go 3 and that's 400 degrees, and that's too hot.
On May the 18th, 1971, the United States Senate met to vote on a motion to end funding the SST project. President Nixon had worked hard to persuade the senators to keep on with the project, but without success. The Senate voted 58 to 37 to kill the Boeing 2707.
I think that Kennedy's decree that the SST should be bigger, better and faster than the European rival did cause major problems for Boeing and for the whole project right throughout it, because they were always aiming for this kind of Kennedy standard of Mach 3 and all the problems that are associated with flying at Mach 3.
I think that was too hot. It just wasn't practical. I think we could go faster than the 2. I think 2.5 would have probably been okay from a temperature standpoint. But certainly any higher than that would have probably not been practical.
Europe looked like it had won the technological race. In 1973, only 18 months after the Boeing SST project was cancelled, Concorde made its first visit to the USA to attend the inauguration of the new Dallas-Fort Worth airport. During its 4-day stay in Texas, Concorde made supersonic demonstration flights over the Gulf of Mexico and proved to be the outstanding attraction in the flying displays, which formed part of the airport dedication ceremonies. But it would soon become clear that Concorde's victory was no victory at all. British Airways flew its first ever regular supersonic flight between London and Bahrain in the Persian Gulf on the 21st of January, 1976. Unfortunately, the route was mainly over land, forcing Concorde to fly at subsonic speeds on large portions of the flight. Next came the introduction of a service to Singapore. But on the 13th of December 1977, after only 3 return flights, service was suspended because of complaints from the Malaysian government about the supersonic boom over the Straits of Malacca on the west coast of Malaysia.
Ultimately, Concorde, though it made it into passenger service, it suffered the sonic boom problem that had dogged the early Boeing project. The Americans banned supersonic flight over the continental United States. Some people said that was in retaliation. Whether it was or wasn't is neither here nor there. It meant that Concorde could only fly supersonic over the Atlantic.
It couldn't meet any of the requirements that we couldn't meet. They don't meet the sonic boom, and they don't meet the takeoff noise, and I guess there are probably only half a dozen or so flying in each airline.
Concorde will never be profitable in the sense of making back the money that it cost to buy or to develop. As far as the airlines are concerned, well, Concorde makes money on an individual flight-by-flight basis because it can charge very high tickets to the kind of luxury passengers that are there.
The system exists now because it's unique and it's high cost and it's one of a kind. And if you want to make a splash, you go over on the Concorde. And okay, Betsy and I were on that one. We went over, take off from Washington about 4:30 we took off from Washington about 4:30 in the afternoon, and you're in a hotel room in London, 9 o'clock. It's great.
But there is one aspect of the Boeing 2707 story that has never been told. A development that was to usher in the age of airline travel for everyone. On December the 22nd, 1965, Boeing's chairman, William Allen, and Juan Trippe of Pan American Airways signed a letter of intent which committed Pan Am to purchasing 25 of a new cargo plane. Unlike the 2707 that was dominating Boeing's attention, the new plane was almost an afterthought. Boeing kept it simple. The design was just a scaled-up 707. They called it the Model 747. The world would call it the Jumbo Jet.
The 747 is an amazing story. And it started back right after the Vietnam War, where the government said, we need to move a lot of material and a lot of people around the world in a hurry.
The 747 was actually developed in tandem with the Boeing Supersonic project. And the aim was to put in the 747 what you couldn't get in the supersonic aircraft, which was freight. It was just meant to be a big cargo plane in the first place.
The Boeing company in 1965 decided to scale up the 707, I think as a freighter originally, but soon realized you could pack so many people into these aircraft and fly them at high subsonic speeds that it was very, very commercially viable, made great sense.
When the dream of supersonic passenger flight died, there was only one plane to step into the breach, the 747. The first 747 entered service with Pan Am in 1970 and started a true revolution in flying. Suddenly, the cost of long-distance air travel was within the budget of the ordinary family. The age of mass air transport was born.
I think the 747 will still be flying in 20 years. It's one of the major developments of this century in aerospace.
Curiously, there's one hangover from the old supersonic project that ended up in the 747, and that was the seating arrangement. When they transformed the 747, the jumbo jet, into a passenger plane, because it was wide-bodied, they could put in a couple of rows, you'd get a lot more seats. And that was the original dream that the supersonic transport had been born with.
But Boeing's interest in supersonic passenger flight did not end with the 2707. In Russia, NASA found a mothballed example of the Soviet SST, the Tu-144, nicknamed the Concorde.
The Russian SST actually flew just a few months before Concorde. And when people saw it, they said, gosh, that looks like Concorde. And that's because, of course, the Russians had stolen, line for line, page for page, the plans of the Concorde and built it themselves.
But the Concorde never entered international service. Soviet technical know-how was not up to the challenge of building a supersonic airliner, not even with the help of stolen plans. The plane proved difficult to fly and fundamentally unsafe. Its last outing was as a flying laboratory to try and solve the environmental problems that had plagued the old 2707. Engineers from NASA and Boeing envisioned a new supersonic jet that could fly 300 passengers at more than 2,400 kilometers per hour and cross the Pacific from Los Angeles to Tokyo in a mere 4.5 hours. But that was precisely the specification the old 2707 cancelled nearly 20 years earlier.
The main thing that's happened is you've gone to high bypass ratio engines, and the engine cycle's changed, and the noise problem isn't as bad as it used to be with a pure jet.
20 years had brought more knowledge about building and flying complex supersonic machines. But the same old problems still stood in the way. A big supersonic craft designed to fly beyond the heat barrier would be incredibly costly to build, fly, and maintain. And there would still be pollution and noise.
There is no technology anywhere that I'm aware of that says that you can bypass, overpass, whatever, the supersonic barrier. It's there. The boom just has to be there. There's so much energy involved when you go through that barrier.
The dream of supersonic transport was an engineer's dream. It was a politician's dream. It was Kennedy's dream. The passengers wanted something different. They wanted cheap tickets. They wanted reliable service. They wanted comfort. And that will always be the future of the airline business.
Now, as a matter of fact, if somebody were to ask me today, will there ever be a supersonic airplane in the U.S., built by the U.S., I would say first you got to define what you mean by supersonic. There may very well be a more advanced Mach 2 airplane, larger, more economical, and so forth than the Concorde. They may very well be. I don't know that. But we are still today not ready in materials to go to Mach 3. We just don't have the wherewithal to do it.
But the dream lives on. Even today, Boeing are still working on designs to push the frontiers of speed for passenger aircraft. The Lockheed SR-71 Blackbird flies at Mach 3. It is made of titanium, and metallurgy and materials technology are advancing all the time. Will the 21st century see the dream come true? This is the challenge and the true legacy of the Boeing 2707. If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.